So today we're going to talk about survival analysis and specifically the Kaplan-Meier method and the Kaplan-Meier curve. So this is just a little overview of what we're going to talk about. We're going to go over what is it, what variables do you need to run Kaplan-Meier. There's a few required variables and there's a few optional ones too that we'll go through. And then also we'll walk through how do I perform it in SPSS with some screenshots. And then at the very end, I'll do a quick SPSS demo in the actual program and kind of walk y'all through how to enter all the variables in there and then also how to interpret the output that you get. Okay, so first, what is Kaplan-Meier method? So y'all have probably all seen a curve like this, especially if you work in oncology. This is very common in the oncology world to see Kaplan-Meier curves or survival curves. A lot of their outcomes are either overall survival, event-free survival. You'll see the 5-year survival rate, 10-year survival rate, et cetera. So that all comes from this. And even though it's mostly in oncology, you can use this for anything. For example, if you have a program and you're wanting to look at if your outcome event of choice is dropout rate, you could use that as well. You can use this for anything. It's not just survival. It's not just for the outcome of a death. But for this presentation and these examples, that's what we're going to go through. So the Kaplan-Meier estimator is used to estimate the survival function. The visual representation of this function is usually called the Kaplan-Meier curve, which you can see below. It shows what the probability of an event is at a certain time interval. So to carry this out, we need 2 required variables. You have to have an event outcome variable, and it has to be unambiguous and occur at a specific time point. For example, alive versus deceased. You can use any event. Like I said, event-free survival uses relapse as their event choice. And we'll go into that. The next required variable is time. So you have to have your time to your event to be able to graph this. It has to be clearly defined, and you can use days, months, years, however you want to define it is totally fine. For survival, we typically do from the start of diagnosis, so the date of diagnosis, and then your ending date is typically either your event outcome date, so date of death, or the date the patient was censored, which means that's the last date of contact and they were alive at that time point. So you will have your dates, you'll transform them into a time variable, and that is required. So your optional variable can be, they call it a factor or your comparison between patient groups. So you can do a single survival curve, or you can have this comparison between treatment groups like you see on this example graph. They have treatment A versus treatment B, or T cell versus B cell, or any sort of patient comparison group that you want to look at the difference between their survival functions. Okay, so let's talk about the event outcome a little bit more. So your event status consists of 2 mutually exclusive and collectively exhaustive states. Your patients are either censored or they had an event. Those are your only 2 options for their outcome or their status. So event examples, which we typically code, I always code it as 1, you can code it as however you want, but I typically code events as 1 and censored as 0. Some examples of this for, like I said, overall survival, your event is death. Event-free survival, your event would be relapse or progression. So for example, you have a patient who died 5 years from diagnosis, if you look on the graph, that patient would have a drop in the curve at 5 years' time. Now, if you're looking at event-free survival and that patient had a relapse 3 years after diagnosis, that patient's drop in the graph moves up and it's now at the 3-year mark because that's now your event of choice. So say you have a patient who did not have an event, they didn't die, they never relapsed or anything, and at the end of the study period, at the end of the follow-up period, they're still alive, or they haven't had a relapse, if that's you're doing event-free survival. That patient is considered to be censored at that time point, meaning that patient did not have an event, they don't contribute to a drop in the curve, but when that patient's censored, anything that happens after that time point does not get included into the data for the graph. So there's 2 types of censoring. You have non-informative censoring, which has no prognostic significance. For example, loss to follow-up. So if we have a patient who we know they're alive 5 years after diagnosis, but they're lost to follow-up, and we're looking, 10 years later, I don't know if they've passed away. I don't know if they've relapsed or anything. We don't include that. So they would be considered censored at that last date of contact. These patients are equally likely to experience the event being depicted in the curve, as are the patients remaining in the study. Another type of censoring can also be called left censoring. It's called informative censoring. So these patients are removed for reasons that may be related to the disease or treatment. For example, stem cell transplant. So sometimes investigators want to censor for events that could affect their outcome, their disease or their treatment or anything like that. And stem cell transplants, one of the events that they'll sometimes censor for. So say we have our same patient, they relapsed 3 years later, but we want to censor for transplant, and they had a transplant 1 year after diagnosis. So we've now censored that patient at 1 year in the graph, but it's not a drop in the curve at 1 year because that's not an event. It's a plus mark or a tick mark on the chart. Clear as mud, right? I'll show you all when we get to the graph, all that. All right, so our time variable, pretty self-explanatory, but the time variable has to be clearly defined, precisely measured, and consistently measured. So a lot of times when you're collecting data, you're not capturing time as your variable of choice when you're entering into REDCap or anything. Typically it's dates, right? So you want to clearly define what your dates of interest are. So like I said, a lot of times we use date of diagnosis as our start date. In the program example, you could use the start of the program if everybody's starting on the same day, but not everybody's getting diagnosed with cancer on the same day, right? So we want it to be consistent. Date of diagnosis is the start date for that patient's time in the graph. The end date will correspond with your event choice. So either your end date is the date of death or the date of last contact, if that's your, if they did not experience a death and they're alive at the last date of contact. So you want to transform those dates into a time. You can do this in Excel. You can also do this in SPSS. It's pretty simple to do. You go transform compute, and then you can transform those dates into a time variable, like the example shown. Okay, so now we have our required variables, what we need. This is how you run it in SPSS with screenshots. So we want to look at the survival outcome of patients with ALL, leukemia, comparing 2 groups. We want to look at our T cell patients versus our B cell patients. You're going to open up SPSS, make sure all of your variables are in the proper format and coded, dummy coded if you need to do that. You're going to go to Analyze, Survival, Kaplan-Meier. And then these dialog boxes are going to pop up. So first, this seems so silly. You're going to put your time in your time variable. You're going to put your status in your status variable, right? Your status is your outcome event variable. Once you enter your status, this define event box will highlight, and you'll click that and it'll open this box on the right, and you'll have to enter what you defined your event as. And like I said, I typically define all my events as 1, but you can do whatever you want. But just make sure that you define your event, and then you'll enter your factor or your comparison group variable where it says factor. So now once you've entered all of your variables into this dialog box, you're going to click compare factor. And this is comparing the factor levels. This is the statistical tests that are run to compare the survival functions between your patient groups. And log rank, Breslow, well, I'll go over the differences between this, but basically it's just weighting the cases differently. So you'll open compare factor, check off what test statistic you want to run, click continue, and then make sure you click options, because these will automatically get checked, the survival table and the mean and median, but the survival plot does not automatically get checked, and that's the graph that is shown up in the output. You want to be sure to open up options and check off the survival plot. So then you click continue and you get your output. There's a lot of additional output that will go in the real SPSS, but this is just an example graph of what would show up from that. So Kaplan-Meier uses each case for as long as the case is valid. So either an event occurred, and it would be a drop in the graph, or that patient is censored by time, and that shows up as a tick mark or a little plus mark on the graph. So tick marks represent censored cases, meaning they have not had an event occur. Each step down in the graph indicates a death or an event occurred. So this is the log rank test, and this is what the output looks like when you are comparing between patient groups. So if you're comparing the different treatment groups or B cell versus T cell, and it tests whether the survival functions are equal between the patient groups. So if you, for example, in this p-value, we would reject the null that they are equal. And these are the different tests. They're all tests for comparing the equality of survival distributions. It's just cases are weighted differently. Okay, so let's open up SPSS. And we'll kind of walk through an example. Can y'all see SPSS?
Yes.
Okay, thank you. Okay, so let's double check that our data is correct and in the right format. So we have code number. This is the patient ID number. This is our lineage. So this is what our factor group is. So we want to look at the difference between pre-B cell and T cell. I have coded it, recoded it over here to a new variable. So it's 0 and 1. We have our time variable, which was calculated from the date of diagnosis and the last contact date. And if the patient experienced a death, that last contact date is the date of death. And then here's our status, which is our outcome variable, which is 1 is deceased and 0 is alive. So let's go to Analyze, Survival, Kaplan-Meier. Can y'all see the dialog box? It's a pop-up, so I didn't know if it. Yes. I'm assuming so, yes. Okay, So let's reset this. So first we enter our time. So we find our time variable, click and drag. Find our status variable, click and drag. So now this define event highlights. You'll click that and we'll enter 1 because that's what we defined an event as. And now our lineage will move to factor. So now compare factor highlights. So you can click that and click your tests that you want to run and click continue. And then be sure to click open options. They all are opening on a different screen. Okay, so this is what it looks like when you just click options. Like I said, it will automatically select those two, but you need to go in and select the survival plot. Continue and okay. Okay, so this is the output. So you have your normal summary of your cases. And then this is a survival table. So this is, depending on how many patients you have, it's every single patient and their status and the survival proportion, like the estimate, it's a lot. If you have a ton of cases, it's very long. But this is really great to use. It shows your time. So this is time in years. So you know exactly as you're going along in the time, this is the cumulative proportion surviving at that time, standard error, number of cases remaining. This can be really helpful when looking at 3-year survival rate or like a specific survival rate. You can go into your survival table and look. So scroll all the way down. Oh, and it has it branched or grouped by your factor group. So these are all B cell patients, and these are all T cell patients. So here you have your means and medians for the two groups. Here's your overall comparison. So here's your log rank test with your significance value and chi-square. And then here's your graph. So the graph that automatically, or that is in the output, isn't always the prettiest. So you can edit it, and you can almost edit everything in the graph. So let's look at the graph. So each drop means an event occurred, right? And then each plus sign or tick mark means that a patient was censored at that time. And this one goes out for a very long time, 27 years, something like that. So to edit the graph, you just double click it. And then you can edit anything. You can edit the titles. You can edit the scale, which I think is really useful. I had an investigator want the survival curve in months, but it automatically goes, the scale is 5. Well, counting by every 5 months is not as easy to interpret. So we changed it to every 6 months, which makes more sense from a month standpoint. So when you double click on the years, it'll open up this properties, and you can go to scale, and it's your min and max. And then this is where you can change your scale if you want. Let's see. Yeah, you can change your number format. So if you don't want any decimals, you can edit that. You can change the color of every line. You can change the weight of the line. I've had investigators say that they were difficult to see on a presentation, so we went and made the lines thicker. You can change that. See how it made it a little bit thicker. What else? Those are mostly what I changed. And then you can edit this so it's not the numbers. You can say B cell and T cell, etc. And then close, and then automatically, you don't have to save it or anything. Just close it and it'll change. And then you can either snip it or copy and paste it into your presentation. Let's go back. So another thing that people will report are a life table. So if you've ever seen a survival curve with like this little chart, and it'll say number at risk, that's a life table. So basically what it's doing is it's looking at each time point on the graph and the number at risk, the number of patients that have not experienced an event that are entering into the next time point. So you can do that. Very simple. Let's open up our data again. You just go analyze, survival, life table. So here I entered the time, and then this will be, wait, let me reset it. Okay, so enter the time. So this is the time intervals that you want to set your life table to. So I typically match it to whatever the graph looks like. So our graph went to 30 and we had it by every 5 years. And then our status, define event 1, and we do want, okay. Okay, so this is what the output looks like for a life table. So your chart that you make is your interval, start time, and then the number entering that interval, if that makes sense. So it looks like this. So this is what the output looks like. And then typically it's presented in this chart fashion. That's all I have. Very short and sweet for Kaplan-Meier. Do y'all have any questions?
Alice, do you want to talk? And I'm throwing you kind of a curveball, so you can feel.
Oh, good.
No, all of the different types of curves that you had to do most recently for one of our investigators.
Yeah.
Do you want to just kind of talk? You don't have to demonstrate, but just kind of talk about those different kind of curves and when they were used, like when they're useful versus like a Kaplan-Meier.
So, yeah, so I had to do, well, we really only reported Kaplan-Meier survival curve. So she was looking at the difference between Down syndrome patients and non-Down syndrome patients and their survival. And she wanted a lot of different survival. So she wanted event-free survival, she wanted relapse-free survival, and then she wanted to censor for transplant for all of those graphs. So basically what that does when you censor for transplant or when you're censoring for additional events, it's shifting everything over. So like I said, that patient who had a transplant at 1 year, if you censor for transplant, you're no longer capturing any of the remaining data. So that patient died 5 years ago, or 5 years later, that's not captured on the graph. So we did a lot of those curves, a lot of different groups. The interesting one that I had never done before was actually the swimmer's plot. And that was, and maybe y'all have done one before, but I've never been asked to do a swimmer's plot, and it was really interesting. But essentially it was, I wish I had it easily and I could pull it up, but it takes every case. So this was a very small subset of patients she wanted to do this with, so it worked, but it takes every case and basically tracks their treatment on like a horizontal bar. So their survival is the length of the bar, and then you'll have different different icons that demonstrate they had a transplant at this point, they relapsed at this point, they had immunotherapy at this point. So that one was a new one for me, and I actually did that in Excel because I think I looked and you had to have R. Like R has a swimmer's plot package, and I don't have R. I have access to R. So you could easily do it in Excel though. It was fine. But that one was a new one for me. But as far as all the survival curves go, it was a lot. It was Kaplan-Meier, but it was a lot of like changing the data to censor for different events, and then also changing what your end date was. So whether the end date was date of death, which would just be overall survival rate, versus shifting it. So now, or like, like the curve would then be lower if your events are happening earlier, if they're relapsing, that's your event. So that's really, it was a lot of curves, but yeah. So I think that's one thing that is important to know, that when you're like event-free survival, so if you have event-free survival, but you're censoring for transplant, transplant's not an event. So I think that is what gets confusing of what gets censored and what's considered an event. So they had their transplant, that's not a drop in the curve. That's just when their data stops from that time point.